Okay, in this video lesson, I'm going to go over factoring polynomials. Now, polynomials is just a term. It describes like a mathematical expression that includes, coefficients and variables as well as exponents. It's in any number of terms, that are separated by addition or subtraction. So you can see here, like in example 1, we have this polynomial 8x squared plus 24. Now we're going to factor it. When I say factor it, we're going to look for the terms or the factors that when you multiply them, you get this expression. So it's kind of like we're working backwards. If you're given two terms to multiply together and you end up with an expression, now we're going from the expression to the terms. All right, so let's just look at example 1. We have 8x squared plus 24x. Okay, well, the first thing we're going to consider is what is the greatest common factor of 8 and 24. Like, what number can both of those be divided by? And it is 8. So I've shown here in this example that the factors of 8 are 8 times 1. Well, then we also have this x squared, and we can consider the factors of x squared as x times x. When you multiply those two, you get x squared. And then 24 over here, the factors of 24 is 8 times 3. Well, what they have in common then is the 8. So we can factor out the 8, and that becomes one of our factors. And then the other factor is what we multiply 8 times to get to that expression, or what is remaining from each term. If we factor out the 8, well, we have this 1x squared. So here's x squared. And then over here we had the 3. So that would be x squared plus 3. So this represents the factors of 8x squared plus 24. Let's look at example 2. I've done the same thing. So 12x squared, x cubed actually minus 18x. Both terms actually have an x. It makes this one a little different. But the 12 and the 18, well, what is the greatest common factor? Well, you always start with 12, the lowest coefficient, if you will, but 12 does not go into 18. 18 is not a multiple of 12. So then we could go to, say, 6, and 6 does go into 12. It's the next largest number that's divides into 12, and it does go into 18. So I've written down the factors, or 6 times what equals 12, that's 6 times 2. And then this x cubed, we could think of that again as x times x times x. And then the factors of 18 would be 6 times 3. Now, this is a negative 18, so we could call that 6 times negative 3. And then we bring down our x. Well, when we factor out what they have in common, we have a 6 and an x. Both of these terms share a factor of 6 and x, so 6x. And then what we have to multiply 6x times to get to 12x cubed, well, that's what's remaining, and that's the 2x squared, so 2x squared. Again, if you multiplied these two together, you would get 12x cubed. And then minus 18x, that's 6 times negative 3. Or 6x times negative 3 would give you negative 18x. All right, moving on. Let's go to example 3 and 4. Very similar, 2x squared minus 20x to the 5th. Again, I always look at the coefficient 2. And does it go into 20? Yes. So that's going to be the common factor of the coefficients, the 2. Then we have an x squared. Well, notice here we have an x to the 5th. Okay, so what I've done in this example is I've just shown x squared as x squared down here when I listed the factors. The reason I did that is because x to the 5th, we could think of that as x squared times x to the 3rd, because remember, with like bases, we add the exponents. 3 plus 2 is 5. And the reason I'm doing that is to show you that they share a factor of x squared. So we're going to factor out the 2 that they have in common and the x squared, and that's what goes here outside of the parentheses. Now, what remains, you'll notice we took out all of the first term. Well, that doesn't mean it goes away, but we have to multiply times 1. So 2x squared times 1 is 2x squared. And then the minus 20x, what's remaining is 10, and it's a minus. So minus 10x cubed. And when you multiply 2x squared times negative 10x cubed, well, 2 times negative 10 is negative 20. And x squared times x cubed is x to the 5th. All right, and the last example for factoring by greatest common factor, I did one here, 21x squared plus 70x to the fourth. Same thing, 21 does not go into 70. So the other factors of 21 would be 7 times 3. 7 does go into 70, so that's what I factored out, 7. And then x squared is what the two variables have in common, is a factor of x squared, so I took x squared out. What was remaining is 3 plus 10x squared. And again, you could always look at what you think are the factors, and if you multiply them, you need to get the original polynomial that you were given. All right, now, for the remainder of the video, I want to look at factoring by grouping. So we have a couple of examples to consider. And it's just like you're using the concept of greatest common factor, but we're going to start with grouping. So here is a polynomial with 4 terms, 4x cubed plus 3x squared minus 28x minus 21. What we're going to do is you'll notice that all 4 terms do not share an x. So we cannot factor out an x. They also do not have any common factor when we look at the coefficients. 3 does not go into 4. It actually doesn't go into 28. It does go into 21, but there's nothing common amongst the coefficients as well. But what we can do is we can group them. And we're going to end up with what's called a common binomial. But if we group 4x cubed plus 3x squared and we just look at those 2 terms and we factor out what they have in common, what's in common is this factor of x squared, because x squared is part of x cubed as well. So I'm factoring out x squared. What's remaining is the 4 and this 1x here, because remember there are 3 here, so 4x. And then all that's left here is the 3, because we took out the x squared. Okay, in the other 2 terms that we're grouping together, negative 28x minus 21, they're both negative, so I'm going to factor out the negative. And if I look at the coefficient of 28 and this constant of 21, the greatest common factor of 21 and 28 is 7. So I'm factoring out a negative 7. And then again, I think about what's remaining in these factors. Well, negative 7 times 4 is negative 28, and I have to have that x as well. And then 21, well, that would be negative 7 times 3, positive 3, to get that negative 21. So now you can see that what we have is this common binomial polynomial of 4x plus 3. It's 2 terms, that's why we call it a binomial. And this one is also 4x plus 3. So that one binomial is one of the factors when we factor it, 4x plus 3. The other binomial is where we take this factor of x squared that we took out of the first 2 terms and the factor of negative 7 that we take out of the second grouping. So x squared minus 7 is one term, and the common binomial of 4x plus 3 is the other one. All right, and then in example 6, it's again the same thing. I just did an additional problem. We have 2x cubed minus x squared minus 20x plus 10. Well, in this one, we can there's nothing that we can factor out again as far as the coefficients or the variables, but we're going to group the first 2 and the second 2. In the first 2, what they have in common, again, is an x squared, so I take out x squared. What's left is 2x minus 1. When you multiply those, you get back to this expression. In the negative 20x plus 10, they're not both negative, but I am going to take out the negative 10. The reason I do that is because factoring out the negative 10 is going to leave the remaining 2x minus 1, because negative 10 times positive 2x is negative 20x, and negative 10 times negative 1 is positive 10. And you'll notice that we have the common binomial of 2x minus 1. So we put x squared minus 10 together, and then we put 2x minus 1.